So we've looked at what our storage admins do, the past few years. In fact, one of my closest friends at NetApp is our IT storage admin. So, he always seems to be busy. So we've gone and, sat with them and tried to understand what it is they do. And if you generalize what they're doing, it's basically this loop. So every single day they get requests from application teams, from people that are using storage saying, do something for me. Could be provisioning a volume, could be trying to improve some performance problem. Maybe they're doing an upgrade. So there's a whole bunch of requests that are coming in every single day. And then they take some actions. And if you think about how they're taking these actions, right, it's essentially through experience and through reading documentation. So over time, they've learned, here's how you do something. Here's how you configure a volume. Here's how you upgrade systems. And there's many sources of documentation. So there's stuff that we publish online. Most IT teams have their own playbooks or runbooks, if you will. So they combine all of these pieces of information to take these actions. And then they monitor the result of their actions to see if they meet certain SLAs. And they're just constantly living this loop. Okay. And if you remove the storage admin from the picture and just think about any system administrator, it's really the same story, right? You have some requests, you take some actions, and you look at the result of those actions. And you go through this loop constantly. So one of the things we wondered about, because we get data from telemetry data from so many different storage systems that represents the actions that so many different storage admins are taking, right? Literally, tens of thousands of storage admins. One of the things we asked ourselves is, are all storage admins made equal? What do you all think?
No.
Yep.
That's a great doing this job, honestly.
So we actually studied a heck of a lot of data, and we found that the outcomes that our admins get across the customer base form a bell curve, which you'd imagine. There are some people that are doing incredibly well. So we have over 1,000 customers that have not had a single failure in the last 2 years. It's a pretty remarkable achievement.
So was that the criteria for this bell curve?
Yeah.
And what's the criteria for the experience level of the admins?
We don't know that.
Okay.
Yeah. All we can see is outcomes.
Okay.
We can see what actions they've taken and what outcomes.
But no inputs.
But no inputs, yeah. And we can sort of speculate, right? But we see some customers and their admins doing remarkably well. Yeah, and this is actually an availability curve. But we've done this for a few other parameters as well. You see a bunch of people struggling, right? Very often we see this in the sort of commercial customers, in countries that are outside the US where they perhaps don't have a lot of that storage admin talent. And then you see a large average, they're doing okay. And so the question we asked ourselves is, okay, how do we get people to the right side? Okay, now that we know this loop that admins go through every day. And so this is what we're trying to do, right? So our definition of AIOps is using AI, and I'll explain what we're trying to do, to essentially make every storage admin a super admin, if you will. We don't want to get the admin out of the picture. This is very similar to a self-driving car. One of the reasons, I'm sure someday we'll have a truly self-driving car, but you still have a human in the loop today to make some judgment calls, right? So I don't think we're there yet where we can completely automate everything. You still need a human in the loop to make some judgment. But the role of that human is going to shrink substantially. And we're going to use AI to essentially make all of them really good. And let me explain this some more. So the key thing that we noticed, actually going back to this loop, the key thing that we noticed is that the way admins understand something is off with the system essentially is by looking at a bunch of logs, numbers, events, things like that. And if you squint, all of those things can actually be converted to numbers. A set of log messages or a set of events can actually be converted to numbers. So the key idea is that we can convert everything to essentially, numeric time series data. And so we're trying to build a generic AIOps engine that consists of two parts. One is what we call a metrics engine, it takes a very large number of numeric time streams. Okay, so examples of this are things like CPU utilization, IOPS, latency, response time. We can, like I said, we can even look at events and convert those to numbers. Okay. And then we're building some basic primitives. Once I have these series of numbers, I can start asking interesting questions. I can say, are there anomalies in these time series? Or which metrics are correlated? I can do things that are even more sophisticated. I can do this thing called causal analysis. I can ask if a certain metric is the cause of something else going bad, right? It's a little difficult to do. And then there's another very powerful primitive that we're adding here, which is what's changed. Very frequently, a storage system will fail, or performance will go wrong because an admin changed something. And now we can proactively detect what's changed.
So how is the engine constructed?
So you mean internally, what's the mechanics of it? So we're using a time series database, okay? And we're building some sort of APIs at the front end that let you pass in any kind of time series. Right? We're doing some work basically to look at common logs and then convert those to numbers, right? And then on the output of this time series database, we have these primitives. Okay.
And so those are algorithm primitives, and is that where the AI is coming from?
Yeah. So the way we do this anomaly detection or correlation, forecast, any of these things is a combination of machine learning techniques and some statistical techniques.
Okay.
Yeah. Some of these things you can do with simple statistical techniques. For others, we use machine learning.
And on the input, is it only from the storage systems, or
It could be from anything.
From applications?
From just about anything.
Okay.
So that's why I'm saying it's a generic AIOps engine.
Okay.
Our idea is once this is built, and this part of it's like 70% done. Once this is ready, we can plug it into anything. We can plug it into Cloud Insights. We can plug it into our unified manager tools. You could plug it into some third-party tool, doesn't matter. We're even contemplating open sourcing this thing, right? And if you look at a lot of startups, this is a hot space, as you all know. And if you look at a lot of the startups in this space, they're really focused on this part. Okay, they're all.
Do you already integrate with other AIOps engines?
No,
or
no,
not yet.
No.
Okay.
I'd say what we're doing is similar to what they are doing, right? Except we are thinking about giving it away. Okay.
So when you say plug it in, this runs in the cloud?
No. This is designed as a bunch of Docker containers that deploy anywhere you like.
Yay.
Right? It's not a cloud-based service. And we did that deliberately because we have run into a bunch of IT teams that say, we're not sending this kind of telemetry to the cloud, right? So, yeah.
This is more to the edge kind of thing?
Sorry?
Yeah, are you actually putting closer to the infra itself to have the kind of almost real time kind of?
You can deploy this anywhere.
Okay, so if
It's very lightweight, just a bunch of
So it's
containers.
kind of a tiny, small time series
Yeah.
database, right?
Yeah.
Okay, cool.
if you were in an air-gapped environment and you couldn't use auto support, could you use this?
Yeah, you could. Yeah. This is designed to be deployed pretty much anywhere. Yeah. So like I said, we've made a lot of progress. Now here's the hard part, right? This is the secret sauce. From this, we can detect what's going wrong. Okay. Then I need to take some action. Like, for example, if I determine that my storage system's performance is getting worse, and it's because of this condition that has to do with, too few inodes in that volume, something like that. I'm making stuff up. You have to decide how to fix it. This is the really hard part. How do you learn what actions to take, right? In our dream world, what we would say is, for this thing that we have observed, here's a piece of code that you can run that's going to fix the problem, right? Here's an Ansible script that you can deploy. Now, the information to do this is there, but the problem is it's in lots of different places. It's there in these IT runbooks. It's there in the online documentation. It's perhaps there on Stack Overflow, on Reddit. So we're trying to write a program that essentially goes and reads these documents and understands what actions to take, and B, converts those actions to code, right? So you can imagine that's incredibly hard to do. And the state of the art isn't quite there yet. So we're partnering with a couple of universities, and we're starting to make some progress here.
Have you thought about, as another data source, inputting kind of like blog posts or message boards where things go wrong and people complain about it and they eventually figure out amongst themselves how to fix it?
It's meant to be generic. So yeah, blog posts could be that, case notes, so we use ServiceNow internally, reading those notes. So if you can solve this for any set of notes, then you can apply it to any text. But like I said, this is an incredibly hard problem to solve. So we're going through it step by step.
You're sort of mixing the concept of knowledge and wisdom to a certain degree. So what you're talking about here is building a better sort of knowledge-based system that can answer a question when you see a problem. And there's a difference in the sense that a lot of what, many storage admins would have done is they would have had long-term knowledge, which is more wisdom of, well, don't do that because that's a stupid way to implement it, or if you do that first and then something else happens, it'll break, or, all those sort of things. Like, for instance, just something as simple as decommissioning stuff. Who's using this today? That sort of thing.
Yep.
So aren't we at risk of basically dumbing down the skills of certain people in the organization and then ending up in a position where when something really does go badly wrong, we haven't got anybody with the skills to go and fix it?
So I don't think the idea is to get the human out of the loop. It's essentially for the human to do a lot more.
But the human's actually not actually learning at this point.
No, I don't think so.
They're clicking and responding to what you're telling them to do.
See, this is a dream world. This is never going to be perfect, right? It's never going to learn everything. Humans are always going to be smarter than machines. Okay, at least.
So you're putting it like augmenting the.
Yeah. It's augmenting the human,
Okay.
right? And for certain things, I think it can replace the human. But there'll be a lot of stuff where it just won't. So I think the human being continues to learn, probably even has more time to learn, right? Instead of fixing mundane things.
But they're not
That's
actually.
hard, right? Because it's kind of a chicken and egg thing, right?
Well,
if you're
I
so
think in the
used
first
to
slide,
this,
all the people that are
the other guy is going to like,
they
okay,
are-
I'm cool with this, and I'm not going to do anything, and
They don't
suddenly the learning just goes down.
So let me help you think about this
dumbing it
differently.
down, right?
I was actually, let me help you think about this differently. I was actually in this room with 7 of NetApp's largest customers. And they said, we'd love to share all our IT runbooks with each other. Because we all know something, and we all benefit if we share this information. And today there's no system to do that. You can think of this piece of software as being that mechanism to share that knowledge across the board.
How do you correlate telemetry data that you have access to from like Active IQ or Cloud Insights to the actions that are showing up in ServiceNow and case notes and outside of that environment? I mean, so
It's hard to do, and I'll give you a specific example. I'll give you a specific example of that.
Okay.
Right. In fact, any more questions about this slide? If not, I'll go to that example of what we do today. Yeah. So this is aspirational, right? We're never going to get there 100%, at least not in the foreseeable future. But to the extent that we can do some of this and augment the human, I think we'll all be better off. Yeah. And we have taken some baby steps in that direction. Okay, so to answer your question, so I'll give you a specific example. One thing we've found, so we've already started doing AIOps in some form here. We can look at telemetry data, vast amounts of telemetry data, right? And we can see configuration changes. And then we can also look at cases that have been opened. And if you have sufficient data, you have large numbers of these cases and configuration changes, you can start drawing inferences. You can say that these changes resulted in that case. And then you can get a human to go read the case and actually verify that's true. And this is something we've already started to do. So in our ONTAP systems, there's a flag called cluster failover. And it's supposed to be set to true. So what that means is if you've had a failure and you've switched to a particular node, after that node's back, right? The node that fails back, you switch your volumes back to the recovered node. Now, it turns out that a lot of storage admins, not a lot, I mean some storage admins, set this cluster failover flag to false after a failure. And they forget to set it back to true. And so then things don't fail fail back after a node is recovered, and they're running in degraded mode for a long time. So we actually figured this out by mining the telemetry data we get and looking at a whole bunch of cases, right? We did this automatically. And we said, yep, these two are connected, and we could actually verify that from the case notes. So what we have done today is we have a mechanism. So you can think of our metrics as this telemetry data, this ActiveIQ telemetry data. We can detect that this flag has been set to false when it shouldn't be, right? And as Marty was explaining in this tool Unified Manager that runs on premises, we have a fix-it mechanism. So you can click a button and it'll go and fix it for you, set it back to true. Right? There's very rare cases where it's false. So the reason we still have the human in the loop is there are situations, and they're very rare, where that flag has to be set to false. So we still want the human to be the judge of whether to set that true or not.
But speaking to what he was saying before, that is kind of a danger. If you're, if the main storage admin goes on vacation,
Yeah.
someone junior sees this tool and doesn't realize, or it's not documented, which that happens all the time, there was a reason to set it to false. Like, is there any way to ingest okay, my situation is different and this should be false, so that flag never comes up?
I mean, again, in the that would be the aspiration, right?
Yeah.
Yeah. But you have to get to this. It's a very complex problem, so you have to get to it with several baby steps. Yeah.
Site knowledge is a real pain, though, because things get done for various reasons.
Yeah.
And you don't want to touch something that you know works. And sometimes, that the reason for that site knowledge is lost in the mists of time.
Yep.
And you never want to change it, or there's a very good reason, or there's a bug, or there's some other thing that you know about. So it can be really tricky to get past that site knowledge issue.
Yeah, you're absolutely right, right? Which is again why we don't want to remove the human from the loop completely, right? But for example, if you figure out that 5,000 admins are doing the same fix all the time, then perhaps that can be automated and you remove the human from the loop. Or what some of the startups do, if they observe that someone's within a particular site, they're making that same action every week, then they say, yeah, I can just automate that. Yep.
What about in terms of you wanting to have a set of standards that you do, and you want to keep a view of making sure that your environment is to your standard and hasn't been changed and moved outside of that? So your own sort of individual or internal compliance, for example.
Yeah. So we didn't talk about that, but that's kind of what we have in ActiveIQ today, and we're doing more there. So we can detect what is a golden config, or you can specify what that is from a storage perspective. Right?
But so a lot of what you talked about today is more around the setup and the configuration of the system.
Yep.
But that might extend to things like threshold limits on volumes and free space and growth and things like that are very specific to the way I want to run my environment.
Yeah.
So can you build those in yourself and add those on top of what?
You absolutely can. So the mechanism we provide for you is APIs, right? Okay. And so like if you look at our own internal IT, they can consume these APIs, which can tell you about capacity. They can also tell you about forecasts.
So,
right?
But you've got to do that yourself in terms of a comparison. You're taking the data and then
that's right.
You'd have to do that yourself.
Right.
Is there an inference engine in ActiveIQ?
Infer what though?
Well, I don't know. You're talking about AI. You're talking about learning, machine learning, deep learning, but all that generates some sort of a neural network kind of configuration that would be used by an inference engine to make some insight on some action. Does such a thing exist in ActiveIQ?
I mean, so today we use machine learning to make some inference. Like I'll give you a very simple one, which is we tell you that if you upgrade your system from this version of ONTAP to that version of ONTAP, these many risks are going to go away, right? Or sometimes we can tell you that this version of ONTAP is better suited for you than that newest version, based on your configuration and based on what we've observed across the customer base. Right? Would you call that an inference?
I don't know. You could call that a correlation. There's lots of ways to get to that information. One of which is AI deep learning kind of solution, but you could do that with basic statistics, really.
I mean, I guess there's a fine line between statistics and machine learning. In this case, we actually use some machine learning techniques to do this.
Well, correlation isn't always necessarily causation.
Yeah.
So it's very difficult to delineate, and having the human element will make the difference.
Yeah. Oh, here's another thing we try to do, sort of work. We're going back to it. We have this way. One of the very popular reasons our customers use ActiveIQ is what Marty showed you, the wellness or risks, right? Configuration risks and such. And one of the things we're doing is we actually did this is write a program that reads our docs and automatically figures out what the risks are, right? So because our documentation will say stuff like, for this condition, don't set this flag to true, or for this condition, set the timeout to 300 milliseconds, things like that.
So what would be really cool is to take that, and especially if I do have a compliance regulations that I need the configs to be a certain way, and I don't want to listen to you about the risk because it's going to break a compliance rule.
Yeah.
So it'd be really cool to say, this is all this, and then compare that to my compliance rules, my golden configs that I need to keep, and come out with an output so that when I look at my dashboard, it reflects the reality of my situation and not what NetApp's golden config says I should do.
That's true. I mean, that's a good idea. Yeah.